Good morning, friends. Today we'll start our lesson 5. Myself Pragyandip. So our lesson 5 will start with coenzyme. The protein part of the enzyme is not always sufficient to bring about catalytic activity. Many enzymes need certain non-protein factors for catalysis. So these may be organic or inorganic in nature. So these are known as coenzymes. It is termed as a prosthetic group when they are tightly held by the enzymes. Sometimes it is also known as cofactor also. That means the non-protein part of the enzyme is known as coenzyme because the protein part is known as your apoenzymes. Next, coenzymes are second substrate. Now, they are also known as co-substrate. Why? So I will pause for a second and let's think about it, and then we will find out the answer. Since they have affinity towards substrate comparable with the enzymes, they are known as coenzymes or co-substrate. Coenzymes undergo alteration during a biochemical reaction which are later generated. That means it behaves like enzyme. That means enzyme takes part in the reaction and it again becomes free. So like coenzyme also become free after taking part in the reaction. And this is in contrast to substrate which are converted into the product. And because substrate converted into product, because coenzyme does not convert into a different compound, it again becomes free. So it behaves both like little bit like enzyme and little bit like substrate because it helps in group transfer and other things. Then coenzymes from vitamin B complex. Most of the coenzymes are derivative of vitamin B complex, which we everybody know. Biochemical function of B complex vitamins are extracted through their respective coenzymes. We'll see the classification table. Sorry for the interruption. Coenzyme is your thiamine pyrophosphate, which the abbreviation is TPP, and it is derived from thiamine, the vitamin B1, and the group transfers by this coenzyme is aldehyde or ketone, and the enzyme is transketolase, which is associated with this. Next coenzyme is your flavin mononucleotide, which is also known as FMN, and it is derived from the protein vitamin riboflavin, and the transferring groups is hydrogen and electron, and the enzyme which is associated with is your L-amino acid oxidase. Next coenzyme is nicotinamide adenine dinucleotide, also known as NAD. It is derived from the vitamin niacin. It helps in the transfer of hydrogen and electron, and the enzyme associated is lactate dehydrogenase. Next, nicotinamide adenine dinucleotide phosphate. It is derived from the same vitamin niacin, and it also helps in hydrogen and electron transfer, and the enzyme associated is lactate dehydrogenase. The last one is your pyridoxal phosphate, which is derived from pyridoxine. It helps in the transfer of amino and ketone group. It is associated with the enzyme alanine transaminase. Next is your nucleotide coenzymes. So that means some coenzymes possesses nitrogenous base, sugar and phosphate as well as the nucleotides. That's why such coenzymes are known as nucleotide coenzymes, like your nicotinamide adenine, because it contains the word adenine and dinucleotide. That's why it is a nucleotide coenzyme. It is dinucleotide phosphate. This is flavin mononucleotide. This is flavin adenine dinucleotide. That's why these all are known as nucleotide coenzymes, because it possesses the property of a nucleotide in case of your nucleic acids. Next, non-vitamin coenzymes, which are not derived from the vitamins. Some organic substances which have no relations with the vitamins but functions as coenzymes. Such are adenosine triphosphate, as everybody knows, it is also known as ATP, What it does, it donates phosphate, adenosine and adenosine monophosphate to the substrate. Cytidine diphosphate derived from cytidine CDP. It is required in phospholipid synthesis as carrier of choline and ethanolamine. The last one is uridine diphosphate, uridine base, uracil based. It is helping carriers of monosaccharide like glucose and galactose and required for glycogen synthesis. Coenzyme do not decide enzyme specificity. The specificity of the enzyme is mostly dependent on the apoenzyme and not the coenzyme. That means coenzyme does not play any role in enzyme specificity. That means the binding of the substrate to the enzyme does not decided by the coenzyme. It is decided by the apoenzyme. So next it will be continued in the next session where we will study the biological application. Thank you for listening.